Hello everyone, in this class we are going to discuss about what is modulation. In last class, which is Introduction to Analog Communication, we already discussed about what is analog communication and what are important parts of analog communication. In that, I already told you that in analog communication, modulation and demodulation plays a very important role. So in this class we are going to discuss about what is modulation, what are advantages of modulation and what are classifications in modulation. So before going to discuss about what is modulation and all that, let me give you an example. See this. Consider this as you and this as your friend. Now you have a piece of paper which has some message written on this and you want to throw this paper to him. If your friend is like beside you, then there may be a chance that he might receive that message. But now let's consider that your friend is nearly 10 meters away from you. Now, is it possible that your friend receives that, like you just throw a piece of paper and your friend who is nearly 10 meters away from you receives this paper? No, right? Like you are throwing a piece of paper, but he might not receive this paper because he is nearly 10 meters away from you. Now let's consider another point of view where you wrap this paper around a stone and throw this. Now there may be a chance that he might receive this, because why this paper isn't reaching until him, because now you wrap this paper around a stone and throw this to him. Now he might receive it, because see here, when we throw a piece of paper, it is low in weight. Like when we throw this paper, it will travel up to here point and then it will fall down. But when we put a stone in it, like when we wrap this around a stone, then the weight increases and then it will travel for a long distance when compared with just a piece of paper. So what we are doing is we are adding a stone in order to make sure that your friend receives that. In the same way, in modulation, we will be changing, like we will be having a message signal. This is message signal. Generally, message signal of low frequency. Message signal is a signal which have message, like which have some information, like this is a signal through which the information we need to be transmitted will be there. And now see, this is a message signal. As in, when we take this case here, this is like there is a message written on this paper, right? See, as the paper is low in weight, it can't be traveled up to this point. In the same way, in analog communication, and here, message signal is of low frequency, which means that it won't be able to travel for a long distance. So, in here, what we done is that in order to make sure our message reaches up to him, we increase the weight of the message by putting a stone in it. In the same way, in here, in order to increase the frequency, we will change it into a high frequency by using carrier signal. Carrier signal is generally a high frequency signal which helps in increasing the frequency of a message signal and it increases the quality of communication. Like we will modulate the characteristics of a carrier signal, like the character may be amplitude, frequency or phase, and these characters can be changed with respect to the instantaneous values of this message signal. How? Let's see. For example, consider this is a carrier signal and now we are changing one character, like let's consider amplitude. We are changing amplitude of the carrier signal with respect to our message signal. Now what happens is, see, look at this here, this is same carrier signal, but amplitude varies instantaneously with respect to the message signal. So this is modulation. Modulation is changing characteristics of a carrier signal with respect to message signal and getting a modulated, this is modulated wave, getting a modulated wave. So this is message signal. This same message is transmitted here, but the slight change is that here it is low frequency, but here it is high frequency. And now this is brief information about what is modulation, what's going on in modulation. Now let's see, like, so in modulation we need message signal and carrier signal. So what is message signal? Message signal is a signal which contains message that is to be transmitted. And what is carrier signal? Carrier signal is generally, it's a high frequency signal which we use in modulation, and it has particular amplitude, frequency and phase, but it doesn't have any information. Like we are transmitting information through message signal, or which is known as a baseband signal, but not through carrier signal. We are using carrier signal for better communication. And now, what is modulation? As we said before, modulation is a process of changing characteristics of a carrier signal with respect to the instantaneous values of a message signal and get a modulated signal. And this is all done to make sure that our low frequency message signal is converted into a high frequency signal and transmitted over a long distance. And one more thing we should keep in mind while doing modulation is that, see here, your friend is transmitting 917079. This is a message he is transmitting, and your friend receiving some information like 919191. Like what? Like, is there any use? Like, you are transmitting some information and you did all this process, and but at the end your friend is receiving some information like 919191, but you send 917079. So here, like, though this is all done, like he received the paper, the most important thing is the information that is message should not be altered. Like, he must receive the same information which you send. So in modulation, the most important thing is that characteristics of a message signal signal should not be altered. And now, so now until now we know what is message signal, what is carrier signal, and what is modulation. And now, what are advantages of modulation, like why we are doing this modulation? First one is like, in advantages of modulation we have four. First one is reduction in height of antenna, and next one is avoids mixing of signals, and next one is increases the range of communication, and next one is multiplexing is possible. How? Let's see. First one is reduction in height of antenna. So in earlier days, we used to have a large sized antennas, but these days we have like medium sized antennas. How is this possible? Let's see. Generally, antenna's height is directly proportional to lambda by 4. That is, lambda means wavelength of the signal we are transmitting. So that means if wavelength decreases, then automatically height of the antenna decreases. So that means if wavelength decreases, height of the antenna decreases. See, then how the wavelength is decreased? See here, if that is lambda is, see, then how the wavelength decreases? See here, lambda is generally c by f, that is velocity by frequency. So velocity is constant, so wavelength depends on frequency. So in modulation, so wavelength depends on frequency. See, in modulation what happens is, our low frequency signal is it's converted into high frequency signal. That means low to high. That means there is increase in frequency. And here lambda is, that is wavelength, is inversely proportional to frequency, which means if there is increase in frequency, then automatically there will be decrease in wavelength, which in turn results in, if there is decrease in wavelength, then there will be decrease in antenna size. So through this, by using modulation, frequency increases, then wavelength decreases, which in turn results in decrease in height of antenna. This is how reduction in height of antenna happens. And then avoids mixing of signals. How? Let's see. Let's consider three transmitters which are transmitting signals like this, and see here there are three signals, signal 1, signal 2, signal 3, and they are sending some signals, but they have same frequencies. Like they are transmitting signals, but those are of same frequencies. Now as they are of same frequencies, there might be a chance that they will be mixed. Like there might be chance, like they are of same frequencies, right? So there might be a chance of mixing. So now, like all are of same frequency, there might be a chance of mixing. So in order to avoid that, we use modulation. Like how? See, we will be modulating this signal with 100 kilohertz and this with 200 kilohertz and this with 300 kilohertz. So at the end what happens is, see here, we are same message, like same all the transmitters are sending the same all the transmitters are sending the signal which is of same frequency, but we change the carrier signal. So one will be getting one modulated signal will be getting 100 kilohertz and another one will be getting 200 kilohertz and another one will be getting 300 kilohertz. So though our message signal is having same frequency, then but the final resultant modulated signal will be having different frequencies, like one is having 200 kilohertz, another one is having one is having 100 kilohertz, another one is having 200, another one is having 300. So see here, though the signals are same, but the final modulated waves are different. So through modulation we can avoid mixing of signals. And next one is increase in range of communication. I'm saying modulation increases range of communication, but how? Let's see. Okay, generally consider our message signal which is of low frequency. As I said, low frequency signals cannot be transmitted over a long distance. For example, consider this is a transmitting antenna and this is the area which it covers. Like up to this point it will be transmitted without any attenuation, but after this particular distance from the transmitter there will be attenuation, like there will be suppression of the signal, like there will be some losses occurred and there will be suppression of the signal when we use low frequency signal. What happens is, when we use some particular high frequency signal, then high frequency signal, okay, it will transmit up to this point perfectly, and also it can travel up to this point without any attenuation. After this particular point there it also might having attenuation, but there will be somewhat increase in the range, like here it only travels up to this point. Like see, in before example I told you that you are sending some piece of paper and see here you are sending the same message, but when you throw this it will reach up to only this point, like it will reach up to here and then it will fall down. But when you put it in a put it around a stone, then it will reach up to this point. That means here we are sending the same message, but here when we just throw a paper, then it will reach up to only like 5 meters, but when 5 meters, when you wrap it around a stone, then it will be reaching 10 meters. So in the same way, when you transmit a low frequency signal, it will travel up to some particular distance and then it will get attenuated. But when you send a high frequency signal, it will travel long distance when compared with the low frequency signal. So this is how, like, frequency of message signal is low. That means low frequency signals cannot be travel long distance. So when we use high modulation, then there will be increase in frequency of the transmitted signal, so which in turn results in increase of the range of communication. Next one is multiplexing is possible. So before going to discuss about how modulation helps in multiplexing, let's know what is multiplexing. Generally, multiplexing is nothing but it's a process where you will be sending two or more, like multiplexing is a process like you will be sending, this is a channel, it's considered this is a single channel, you will be sending multiple signals through the same channel. Like you have a, like you will be sending multiple channels through the same channel. So using modulation in multiplexing, what happens is we are sending signals, like two or more signals, through the same channel. If we do not use modulation, there might be we will worry about mixing of signals, but using modulation we can avoid mixing of signals and multiplexing is possible. So this is the main advantages of modulation. Those are reduction in height of antenna, avoids mixing of signals, and increase in range of communication. Multiplexing is possible. So until now we know what is modulation, what are advantages of modulation, and now let's know what is the classifications of modulation. Like modulation means change in characteristics of carrier signal, right? Like we have different types of carrier characteristics like amplitude, phase, frequency. So based on that, like how we are modulating carrier frequency, we have different types of modulations. Like generally we have two systems, that is analog modulation system and this. For now we will go through what is analog modulation systems and what are the classifications in analog modulation systems. Generally it's of three types: amplitude modulation, angle modulation, and pulse analog modulation. And again angle modulation is again divided into frequency modulation and phase modulation. And when we discuss about what is digital modulation systems, we have two types, that is pulse code modulation and delta modulation. So first in this class we will just briefly go through each and every one, and in next class we will discuss about them in detail. So first one is amplitude modulation. See here, this is our message signal. This is our carrier signal. So this is amplitude modulation, that means modulating amplitude of the carrier with respect to what? With respect to message signal. So we are in amplitude modulation, we are modulating amplitude of our carrier signal with respect to message signal, and we will be getting here. We see here frequency of the carrier remains constant in amplitude modulation, but amplitude of the carrier varies with respect to the amplitude of the message signal, and this happens in amplitude modulation. Whereas in frequency modulation and phase modulation, that is FM and PM, first of all, when we discuss about frequency modulation, what happens is, in frequency modulation, frequency of the carrier changes but amplitude remains constant, and we will be getting, like, see, if we consider this as a message signal and this as a carrier signal, then we will be getting, see, as the information, like as the information amplitude increases, frequency increases. As the amplitude decreases, frequency decreases. So we will be getting something like this. See here as the amplitude increases, frequency increases, and when the amplitude decreases, frequency again decreases. So that's what happens in frequency modulation. And in phase modulation is generally, it's similar to frequency modulation, but along with the frequency, even phase also changes in phase modulation. And see, that's what we got here. So first of all, amplitude modulation. See, in amplitude modulation, information is found in amplitude variation. So information is contained in amplitude variations in amplitude modulation, and frequency of the carrier remains constant. And amplitude modulation is mostly used in radio and TV broadcasting applications. And next one is frequency modulation. In frequency modulation, information is carried in frequency variation, and amplitude remains constant in here, and it is mostly used for TV broadcasting, and also it's used for radio and sound broadcasting. And next one is phase modulation, where there will be a phase shift in the carrier signal with respect to the message signal. And next one is pulse analog modulation. This pulse analog modulation is just similar to this amplitude and frequency modulation, but the difference is that in pulse analog modulation, we will use carrier which is pulse signal. So see this, in pulse analog modulation, that is we will be having pulse amplitude modulation and pulse position modulation and pulse width modulation. Let's see what are they. This is a message signal, right? And we have a carrier like this. As I said, in pulse analog modulation, we will be using pulse signal, not a sinusoidal signal. So what happens in pulse amplitude modulation is, in the same way as in amplitude modulation, here also the amplitude varies. So we will be getting this is how amplitude varies. So this is pulse amplitude modulation, and next one is pulse width modulation. In pulse width modulation, we have a signal, we have a message signal, and we have a pulse carrier. What happens is, in pulse width modulation, the width of the pulse changes. See here, it will be like, see, as the amplitude increases, the pulse width increases, and again as the amplitude decreases, pulse width decreases. So this is pulse width modulation, and next one is pulse position modulation. Pulse position modulation, in this, position of the pulse will be changing with respect to the amplitude of the message signal. So here what happens is, this is a pulse, right? Pulse carrier. So in this, what happens is, see this here, in pulse width modulation, width of the pulse changes, but position with respect to another pulse remains constant in pulse width modulation. But in pulse position modulation, width of the pulse remains constant, but this width, I mean like the relay the position of the pulse with respect to another pulse changes. See this. See here, with, I mean position. This pulse position with respect to this pulse is different from this one. So position of the pulse changes in pulse position modulation. And in classification we have, that is, another one is digital modulation, right? I'm not going to give brief explanation about this, because this is not much important in analog communication. It's totally digital communication. Actually, in digital modulation system is like, we will be having a digital signals where we will modulate them. So that's it about classification of modulation. So in this class we discussed about what is message signal, what is modulation, and what are advantages of modulation, and what are classifications and modulation. So in next class we will be going to discuss about what is amplitude modulation in detail and modulation index. Thank you.